we're doing powers of sums and solving by factoring. So first we're going to start with this guy, x plus 2 to the third power. You want the title? We're being recorded. All right, guys, so whenever we have an exponent, it just means this thing times itself that many times, right? So if I wanted to just rewrite this, I would rewrite it as x plus 2 times x plus 2 times x plus 2. Grab your notes out. All right, guys, so when I'm multiplying, at least at this point in our math lives, we don't know any handy-dandy trick to multiply these all at once. So we have to start by multiplying these first two together, and then we're going to multiply in this last one. So I'm multiplying these first two together. I'm probably going to FOIL, or however you guys learned how to do it. We just have to distribute both of these to both of these. So I'm going to start with this one. X times x gives me x squared. X times 2 is plus 2x. Then I'm going to go to this guy. 2 times x is another plus 2x. 2 times 2 is plus 4. We want to make sure this is all in parentheses still because we're still multiplying. It needs to be in parentheses, and then we have an x plus 2 on the end. All right, so I'm looking at this guy. I see that I have some like terms in this one. So I need to combine these like terms. It's going to make my life easier when I'm distributing these pieces. So these ones together make 4x plus 4x. So now what I need to do is multiply in this x plus 2. So when I do that, I want to make sure that this x makes it to every piece on the inside, and this 2 makes it to every piece on the inside. So I'm going to go through and multiply every piece by x to start. So I'm going to get x cubed plus 4x squared plus 4x. Now I need to multiply every piece by 2, so I'm going to have plus 2x squared plus 8x plus 8. So we got that all multiplied out, but again we have some like terms, and you always want your answer to be with all of your like terms combined. So we're going to look at this and see what we can pull out. This x cubed is all by itself, so it's just going to be rewritten. We have 4x squared and 2x squared gives us 6x squared. 4x and 8x gives me 12x. And finally, we just have this plus 8. It doesn't have a friend, so it goes down there by itself. And this is our final answer. It's pretty basic stuff. I trust that you guys know how to distribute. These ones you just want to make sure that you didn't leave anyone out. Everything always needs to be distributed to everything else. All right, now we're going to solve by factoring. Whenever we're solving by factoring, we want to set everything equal to 0. So what all that means is that we want 0 on one side of the equal sign, and we want everything else on the other side of the equal sign. So what I'm going to do is I'm going to subtract 6 from both sides, and I'm going to rewrite this guy how I like factoring things to be written. So x squared minus x, and then a minus 6 because I subtracted that over, and I have equals 0, which is what I want. This 0 is what I want, so we're in good shape. Now I can just go ahead and factor it. I'm going to have an x here, an x here, and now I want to multiply to negative 6 and add to negative 1. So what are my numbers going to be? You raise your hand. Other people can get a chance. I know. Can help the class out by raising your hand. Okay, x minus 3x plus 2 sounds good to me. So now we're trying to solve. Whenever I'm solving and I have one side equal to 0, what I want to do is I want to take each piece, so this one I have two pieces being multiplied together, and set them equal to 0 separately. So I'm going to do x minus 3 equals 0, and then I'm going to do x plus 2 equals 0. I'm going to add 3 to both sides for this one. X equals 3. And I'm going to subtract 2 from both sides, and this one is x equals negative 2. Yeah? For these ones, So you can probably just do the opposite. If it's a little trickier, you might want to write it out. Alright guys, so the reason this works is if one of these pieces equals 0, we're doing multiplication here, so it's just going to, anything multiplied by 0 is just going to give us 0. So that's why we set each piece equal to 0 separately, and we get two solutions. So x equals 3 and x equals negative 2 will both get us 0 on the right side. Yay. Here's our next one. So again, I want to make sure that everything's on one side, I have 0 on the other side. But another thing that's really helpful when I'm factoring is if my biggest degree, so my highest degree is the cubed, I want this term to be positive. So I'm going to actually move these two things over to the left side. So if I do that, I would be adding x cubed to both sides. So I would have x cubed. I would subtract 16x squared. And then I would still have this minus 36x equals 0. You could still do it. I just prefer to factor when the first one's positive. All right, now what do I have to do to this polynomial before I start to do plussing and minusing? Yeah, factor out the GCF. My GCF is x, so I'm going to pull an x out onto the front, and we're going to see what's left over. X squared minus 16x minus 36 equals 0. And now we can factor x, x. All right, now what are my numbers? I want to multiply to negative 36 and add to negative 16. Yeah, Paige. Plus 2, negative 18. Perfect. So again, I want to set every piece I had being multiplied together equal to 0. This time I have this x on the front. It counts as its own piece. And then I have this guy, and I have this guy. So I have to set all three of them equal to 0. So I'm going to have x equals 0, x plus 2 equals 0, and x minus 18 equals 0. So this one's kind of nice because it gives us an answer for free. X equals 0 is one of our solutions. I'm going to subtract 2, x equals negative 2 is our second solution. And then I would add 18, and x equals positive 18 would be my third solution. So you guys might notice a trend. This one we had an x cubed, and we had 3 solutions. So unless something funky is happening, you should be getting 3 solutions when you have a cubed in your starting polynomial. All right, one more of these guys. This one's already set up nice for us, but it's actually like AC factoring. So what's up, Matt? It's kind of weird when people factor without them being in order, but I guess if you can, you don't have to put them in order. All right, so for AC factoring, I multiply 2 and negative 5, so I want them to multiply, to negative 10. Whenever you have a coefficient on the front of your first term that can't factor out of everything. If it's a GCF, then just go ahead and pull it out. If it's not, then it has to stay there. And then we want them to add to this middle term, which is negative 9. So what are my two numbers for this guy? My two magical numbers. Anybody new? Anybody? Thanks, Peanut Gallery. 10 and negative 1. Actually, that's wrong, yeah. Negative 10 and plus 1. So I'm going to rewrite this. Minus 10x plus x minus 5. Now we do some little factor by grouping here. So I have this group here and this group here. I can pull a 2x out of both of these ones, and I have x minus 5 left over. And then I'm just going to pull a 1 out of here, minus 5, 0. And if I rewrite this, 2x plus 1 times x minus 5 equals 0. Set both pieces equal to 0. This one gives me x equals 5. And this one I'd subtract over 1. 2x equals negative 1, so then x equals negative 1 half. All right, that one Just had some tricky factoring. Same deal though, set everything equal to 0. Not quite done yet, almost. All right, look at these 3 different things and see what's different. They have some different things going on. This one has an x in the front, this one has a 5x in the front, and this one has a 2 in the front. So using your fingers, show me how many solutions you think the third one has. How many solutions? I want to see everybody showing some fingers up in the air. How many solutions do you think the third example has? All right, someone who's holding up 3, would you like to justify for me why you think? Jillian? So what would I, like, if I took this guy and I said set it equal to 0, does that make any sense? It does? Oh. Okay, so people who held up 3. Oh. I wasn't going to be that mean. But we do have 3 pieces. Makes sense why you would think there might be 3 solutions. But whenever there is not a variable in this first piece, you can't have a solution from it. So these ones I would set, excuse me, 5x equal to 0, and then my solution would be the x equals 0. This one I would set x equal to 0, and I get my solution for free. This one I set 2 equal to 0. That makes absolutely no sense. That one doesn't give me a solution. This example right here only has 2 solutions. So a lot of people get tripped up whenever they see this thing on the front. They're going to say, oh, I have a solution. It's x equals 0. This one does not give me x equals 0 as a solution, because if I set 2 equal to 0, it makes no sense. This was probably just a GCF that we pulled out before we factored. All right, now you may grab a whiteboard.